Hello everybody, it is Ms. Haynes again. I've got a project for y'all, and this is just sort of the introduction part to it. There's a couple other steps to do, but I'm going to try to facilitate like some group work this time for the virtual students even, and that's going to be interesting. Here's my draft. I've not published it yet. Once I have this video, I'll put it in here, and then it'll all be uploaded. Your scenario is this. You've got somebody who makes earbuds, a company that makes, wired earbuds. And customers are complaining that when they wad up their earbuds and put them in their pockets or in their bags and they get smashed and the wires break off and pull out of the earbuds. So the manufacturer says, okay, we're going to strengthen the wire connections, but we also want to make a protective case to go with it. And that'll help protect the devices from damage. So the idea is you're going to use a design process to sort of develop preliminary designs and provide proof of concept. That means you're going to have evidence that your design is feasible, it meets the design criteria for a 3D printed protective case for earbuds. So I've linked the entire thing. That's just a snippet from it. That's like copied directly out of the PLTW information. This is just what they have on the website. I've made it a PDF and put it right here. Your major criteria, I've got the design brief. Here, I'll show you. So this is the document from the website, and feel free to read through and at your leisure, actually take some time to think about it. I just wanted to have a short video to introduce y'all to what's going on. Here's your design brief. So your client's going to be the earbud manufacturers. Your target consumer is the customer. Designer, well, that's you and whoever else you're working with. Here's a restatement of the problem. And so your design statement would be something like, we're going to design a case for earbuds that will help protect them from wear and tear and just give the users a better end experience. You can make up whatever statement you want to about that, but basically what's your goal with this design? These are the criteria given, these first four here. The first criterion is that the case has got to be composed of two parts with a hinge mechanism. Then you've got to have a design to allow for easy insertion of earbuds into the case. So it takes maybe 7 seconds to put your earbuds in. Then you got to have the case be secure. It's got to store these earbuds, protect them from damage. It won't break open if it's in your pocket. They won't fall out. And then lastly, you've got to have vent holes to allow for air circulation into the case, but don't allow any part of the earbuds to come out of the case. And people keep saying, why do we need circulation? Well, the biggest reason is because, if you have earbuds in your ear, they will get earwax on them. They might get sweat on them. And any moisture will be a place where bacteria can grow and thrive. And then you're going to put that back in your ear. That's a recipe for disaster. So that's why they need it to breathe a bit and make sure that, they don't harbor moist areas for bacteria to live. We got constraints. We got a design submitted for review by, and there's a deadline space there. You can have a 3D printed prototype, which I might be able to do. I need to finish printing y'all's charms first. And limitations in production. We might have limitations about volume and maximum print time. Like for me, I might not want to print a case for everybody if it takes 5 hours to print one case. So phase 1, you're going to have your initial concept sketches. Maybe you're going to have multi-view drawings even. That would be really nice if I get both of those. But the idea this time is we're just going to make sure we get some concept sketches. Okay? That's the very first thing. And that's sort of an individual thing. You can work on your own. You're going to brainstorm a couple ideas. Where did I put the there you go. No, that's not it. Oh, that is what I'm looking at. I've lost track of what I'm doing. So your potential client here, they've already received a design idea from your competitor. But you're fortunate enough to have these schematics. So here's the schematics. This is what the competition, I guess Josephine, has come up with. And this is the bottom part of the case. That's what it kind of looks like from an angle. And here's some information about the dimensions. Here is the piece that has the lid. The lid was designed by Jordan and reviewed by Jeremy, so I don't know. I guess they were working as a team, and one part of the team had the base and the other part had the lid. And so here's the schematic on the lid, and they'll fit together fairly nicely. Alright, so I have both those files in here. So for step 1, for this step, you, on your own, brainstorm a couple ideas for a general shape and function of an earbud case. You can sketch out some concept designs for at least 2 different case ideas. You can use graph paper, isometric paper, plain paper, whatever. Just make sure that your entire idea is clear from your drawings, and then upload your pictures here. I've also linked the checklist and rubric, and your checklist includes, well, design brief, we should probably try to learn how to do that. But the concept sketches is 3 minimum. 2 or 3 should be enough. If you have a third idea, put 3 ideas down. Alright? So all these files here are included right here. And the cool thing is, since you've got someone who kind of knows how to do CAD, I actually put together from these schematics a 3D model of the case. And there it is. Right there. I have the 2 parts separate. What they've done is they made an array of holes in the bottom that are all the same size. They have a little slot in the front that the this tab can come and sort of latch into when it closes. They've filleted these corners in the front so it's not completely stabby in the front part. And then the hinge mechanism at the back, it's got this sort of a half a sphere sticking out on both sides. And on the lid, it's got half a sphere sticking in on both sides. And the dimensions are such that that like the distance here between this flat edge and this flat edge are just a little bit bigger than the dimensions between this flat edge and this flat edge. So if you put them together in an assembly, there's exactly a 0.5 millimeter gap on either side. And that allows your spheres to kind of get close to each other. It allows you to sort of be able to pop that lid in. So I did not ever teach how to do assembly designs. I haven't done that yet. I don't think it's in the curriculum yet, but this is an assembly. Essentially what I did is I took both parts out of here. Come on. There we go. I took both these parts and I told it to put a mate feature in here. A mate just means a way that it goes together. You can have fastened, you can have revolute, you can have sliding, you can have all sorts of different kinds of mate features. And what that does is that limits the degrees of freedom relating 2 of your parts together. So what I did with the revolute is I said, alright, I need to make sure that that where these hinges are, the central axis down straight through these cylinders, these like 3 cylindrical pieces, they all line up, and this guy can rotate around it. So I put the 2 together. I've offset it because when I picked the center of this cylinder and I picked the center of this one, it like moved the whole thing over to here. So this Z equals -17.5. That's just me having to offset it. Don't worry too much. You're not going to have to do an assembly. If I decide I want you guys to learn assemblies, I'll actually do like a video on how to do this. I just wanted to show you what it looked like assembled. And the cool thing is, and I also restricted it, so like the minimum rotation is -90, so that actually brings it down like closed, and the maximum is about 150. I figure that way, like this part here, you don't want this corner to intersect with the base of it over here. So what does that look like? Well, it actually looks kind of cool. You can animate it and see how it looks opening and closing. So you have an idea what this thing looks like. For an idea of size, let me show you something else. Since I have a 3D printer, I can print these things. This is, to scale, a little box. And this little latch piece right here has the little tip that goes in. You pull that out gently, and it's really hard to see inside of. There we go. Oh. Huh. Exponential growth equations are here. But yeah, this is what it looks like, and I don't have any wired earbuds. I should have thought to find some and show you how they fit. But for this size and this shape of case, what ended up happening at school is I had students, they would wad it up. They'd roll it up like around their fingers, and then they'd have a wad of earbuds, and they'd have to shove that in here and like push it on down. And every now and then wires would come back up, and they'd be pushing one wire in, and another one would pop out. So they'd have this whole process of trying to shove it in there and latch it closed. I wish I could get a really good close-up of the hinge. I ended up having to file down with a nail file the two little spherical nubs on either side of the main piece, just so that I didn't feel like I was going to break it when I was shoving this lid piece in there. There's a tiny gap. I don't know if you can really see. Yeah, you can see some of the paper. You can see kind of where some of the gaps are and how it fits. Yeah. So things that students observed with this is it's not super easy to get the earbuds in. There's not it doesn't feel very secure. They kind of stuff in there and almost fill the box up entirely. And the other thing is they said, well, it's so bulky. I mean, that's like almost 1.5 inches tall, at least 1.5 inches this way, probably 2 inches and a bit this way, and it's got kind of a sharp corners on the back where they didn't fillet it, like right here. These are kind of sharp. Where the hinge sticks out, it's kind of pokey. If you put that in like a jeans pocket, that's going to be jabbing you in the leg all day long. And if you're someone like me where I will walk into furniture all the time and some tables are kind of at pocket height, that'll jab it really hard into my leg or break it possibly if I'm walking fast enough and don't notice that there's a table there. So think about that when you're designing, like what sort of shape do you want? Do you want it to be smooth? Do you want it to be slim? If it's going to go in a pocket versus if it's going to go in a purse. I mean, this might be fine if it was just sitting on your desk, but a lot of students felt like, hey, it's not great for a pocket. All right, I'm going to go ahead and unshow that. Yeah, if y'all have any questions, let me know. Something people do sometimes is they say, okay, earbud case. And they look at some designs and they think about shapes and they think about, there's really no brand. They didn't give us any dimensions of the actual earbuds, but you can always do a Google and get some ideas. I'm not going to judge. Try not to copy something exactly. Make it a little bit creative on your part. And that's about it. So y'all have a wonderful rest of the day or the evening, whatever time of day it is when you're viewing this. And if you need anything, let me know. I'll talk to y'all soon. Bye-bye.